Okay, you've got these 3 points in the coordinate plane. This is actually point L here. 1 comma negative 2. 5, 4 is M. 10, 5 is N. We want to find the circumcenter, which is the center of the circle that passes through all 3 of those points. And according to these directions, we want to use the distance formula where HK represents the center, H comma K. And so using the distance formula to the point 10, 5, H minus 10, the quantity squared, plus K minus 5, the quantity squared, equals the distance from the center HK to point N. And you can do similar setups for the other radii from HK to L and from HK to M. So you've got 3 equations, 3 unknowns, but these radicals are all equal to R. So if I take this pair right here, which I've done right here, square both sides, that removes the radicals, square the binomials, that's what I did on this line. Notice that the H squareds cancel out and the K squareds cancel out. And then you can combine similar terms, get the constant on one side, the variable terms on the other side. From here to here, I just noticed that every term is divisible by 2. And eventually, I'm going to use the substitution method. So I solve for K. K is 42 minus 5H. Taking the second pair of equations, and there's actually 3 pairs, didn't matter which you use, but same deal. Square both sides to remove the radicals. Expand the binomials. Cancel the H squareds and the K squareds. Combine similar terms. And you get 2H plus 3K equals 9. And then we're going to substitute this value for K into the other equation and solve for H. And there's what we get. H is 9. If H is 9, plug 9 in for H. 42 minus 45, negative 3. So the circumcenter is at 9, negative 3. Completing the directions, to find the distance from the center to one of the points, use the distance formula. You get the radius as the square root of 65. But in the equation of the circle, we're going to use R squared. So R squared is 65. So there's the general equation, or the center radius form for the center of the circle, for the equation of the circle. And to get it into standard form, expand the binomials, combine similar terms. That's really just the constants. 90 minus 65 is 25. So there's your answer. And real quickly, I thought I'd mention another way to do this problem. Of course, this equation, or this circle, is really called the circumcircle. This is the circumcenter. Another way to do the problem is to find the equations of these 2 red dashed perpendicular bisectors. And the truth is that if I found the midpoint here and the perpendicular bisector of LN, it too would pass through that circumcenter. So if you find the equations of 2 of the perpendicular bisectors and then find out where those 2 perpendicular bisectors intersect, that's the circumcenter, because this point is the same distance from the endpoint of this segment as it is to that vertex, and so on, because they're on the perpendicular bisectors. So if you find the slope of LM, then the perpendicular to LM is the negative reciprocal, negative 2/3. The slope of MN is 1/5. So the slope of the perpendicular is negative 5. If you find the midpoints of each of those segments, then you can write the equations of the perpendicular bisectors. Using point slope, convert to slope intercept, set these equations equal to each other. That is, this has to equal this because they both equal y. That's what I've done up here. This kind of looks familiar. It's the same equation we got when we did the HK method, x equals 9, and we can continue on y equals -3. Find the distance between the center and any one of these vertices, and you've got the radius. Okay, there you go. Hope that helped. If you have any questions, post a comment.